Hey grade 7, welcome to another edition of Mr. V Teaches Math. In today's video we're going to be going through and we're going to be solving some proportions using equivalent ratios and using equal signs and all kinds of fun stuff. And so our goal today is to compare quantities using ratios and determine equivalent ratios. Good times, good times. So here's the problem that we're going to start working with. Snowboarding is the fastest growing winter sport in Canada. A recent estimate of the Canadian male to female participant ratio is 3-to-1. So for every 3 guys that snowboard, there's 1 girl that snowboards. Ramona School is going on a ski trip, and 24 boys have signed up to go snowboarding. So the main question is, how many girls sign up to go snowboarding if the numbers match the Canadian ratio? Okay. Now, before we kind of get into some of those solutions, what we're going to do is look at this. This is like a little note. So for the solutions, you can write equivalent ratios. Now, equivalent ratios are just 2 or more ratios that represent the same comparison. So for example, 1 to 3 is equal to 2 to 6 is equal to 3 to 9, all those things. You can write equivalent ratios by multiplying each, or dividing for that matter, each term in a ratio by the same number. This same number is called a scale factor. You notice that it's highlighted. It's an important definition to know. The definition for a scale factor is a number that you can multiply or divide each term in a ratio by to get the equivalent terms in another ratio. It can be a whole number or a decimal. For our math stuff, we will always use whole numbers as our scale factors. But here we have some examples. We have the ratio 1 to 3 equals the ratio 2 to 6. This is a proportion. And what you do is you look at first term in the left one, first term in the right one. To get from 1 to 2, you have to multiply by 2. But the scale factor has to be the same in both. So if you multiply the first term by 2, you have to multiply the second term by 2. So that's to give it the same comparison. So you show it like this as a ratio, or you can show it as equivalent fractions. 1 over 3 equals 2 over 6. And again, the scale factor is 2. Same with over here, 16 to 12 equals 4 to 3. And you use the scale factor of 4, but you're dividing by 4 rather than multiplying. So 16 divided by 4 equals 4. 12 divided by 4 equals 3. Same over here. So the scale factor is divide by 4. Okay? Now, for the solutions, we're going to multiply to write equivalent ratios. And so we're going to be determining the number of girls who go snowboarding on this trip. Remember, the Canadian ratio is 3-to-1. So that's the one that we're going to start working with, like this. 3 over 1. And we're going to just start writing out equivalent ratios. So that's 6 to 2. If I triple it, it's 9 to 3. Could be 12 to 4. Could be 15 to 5. Okay, so these are all getting bigger. Basically, what I want to do is pick a scale factor that's big enough to get me to 24 guys, right? Because it's guys to girls. And so if I want 24 guys, I have to multiply 3 times 8, which means I have to multiply 1 times 8. So it's 24 to 8. So using this ratio, 3 over 1, I can say that it equals 24 over 8. So for Ramona School, if 24 boys sign up to go snowboarding, and it follows the Canadian ratio, 8 girls should sign up to go snowboarding. Okay? The other way is to calculate the missing term, and the way that we do that is use the colon method. It doesn't sound very great, but show the ratios using a colon. So 3-to-1 equals 24 to some number. Okay? Canadian ratio, Ramona School. Okay? Guys to girls, guys, number of girls. And here's where we need to figure out a scale factor. So we look at first term here to get from 3 to 24, multiply by 8, and then multiply by 8 for the second number as well. Okay? Because it's got to be the same for both. The scale factor is the same. So that means that the question mark equals 8. Okay, so that's using that method. I like this method a lot, personally. So, a few reflecting questions before we do some practice. The questions are things like, how do you decide what scale factor to use to solve a proportion? Well, it really depends on whether or not the second ratio in a proportion is getting bigger or smaller, because you need to figure out if you're going to be dividing or multiplying, or some combination of both. Secondly, you have to figure out, like say we're going from 3 to 24, you need to know that you have to multiply 3 times 8 to get to 24. Okay? You also need to make sure that you, well, the second question here, how can you create a ratio that is equivalent to another ratio? Well, you can use your scale factors. You can multiply by a scale factor of 2, you can multiply by a scale factor of 3 or 4 or 5 or so on and so forth. Same thing, you can divide by a scale factor as well to get an equivalent ratio. How can you determine whether two ratios are equivalent? If you can apply the same scale factor on the left-hand one and apply it to the right one, then it's equivalent. And what I mean by that is if we have something like 16 over 12, and I want to know whether or not it's equivalent to 4 over 3, I have to figure out if I can, in this case, divide by the same number to get to the one, from the one on the left to the one on the right. So I know that 16 divided by 4 is 4, and 12 divided by 4 is 3. So if that scale factor is the same top and bottom, or first term and second term, if you use this way, if that scale factor is the same for both numbers, first term and second term, then they are equivalent. If it's a different number, then they are not equivalent. Okay. Last question. Suppose you are given a proportion that has one term that is missing. How can you determine the missing term? We kind of did that a little bit over in our previous example, but to answer that question, we're actually going to get a chance to go through some of these questions together. So here we have 18 to 9 equals 8 to some number. Now, this is a problem that's actually going to require a couple of steps to figure out. Because first, I can't get from 18 to 8 using a whole number, dividing by a whole number. So I actually need to simplify 18 to 9. And I need to divide both these numbers by 9. So if I divide 18 by 9, I get 2. If I divide 9 by 9, I get 1. Okay? So scale factor here, divided by 9, divided by 9. Now, what I can do is I can take that equivalent ratio, 2 to 1, and say that it's going to be equal to 8 to some number. Now to get from 2 to 8, scale factor of times 4, and then times 4 here, which means that the question mark or the unknown number equals 4. Okay? So these are two-step problems where you have to simplify one of the ratios first before you can find out the larger ratio. Okay? Same thing over here. We need to simplify 15 over 25. I'm going to divide both these numbers by 3. And I'm going to get 5 over 5. No, sorry. I'm going to divide both these numbers by 5. Sorry about that, guys. It's like, wait a second, 25 is divided by 5. So I get 3 over 5. Sorry about that. Now my new ratio, or my new proportion, is going to be 3 over 5 equals 18 over an unknown number. Okay, so to get from 3 to 18, it's times 6, scale factor, first and second term, or top and bottom number. 5 times 6 is 30. So I can say then that 15 over 25 is equivalent to 18 over 30. Okay? These last two are a little bit simpler. 2 over 5 equals some number over 15. To get from 5 to 15, multiply by 3. Same thing over here, 2 times 3, which means that it's 6. So 2 over 5 equals 6 over 15. And then over here, I'm going to rewrite it just for some more room. 12 over 18 equals 2 over some number. And divide that by 6, divide that by 6, which means that my question mark equals 3. So I say that 12 over 18 equals 2 over 3. So that's some two-step problems, some one-step problems to find a missing number in a proportion. Okay? So hopefully you understand a little bit better about how to solve for missing numbers and how to solve for proportions.